All right, so welcome to the Generative AI in the Real World podcast. Today we have Robert Nishihara, co-creator of Ray and co-founder of Anyscale. So Robert, welcome to the podcast.
Thank you so much. Good to see you again.
So we'll talk obviously about Ray. And for people who are not familiar, Ray is an open source project that came out of Berkeley that has become kind of like the default AI compute engine, the default foundation layer. And I've been writing about Ray for many years, and recently I wrote a series of posts about how I was observing companies building custom AI platforms, and a common substrate seemed to be Ray across many companies. But so the reason I bring this up is because Robert then has a great perch because he gets to work with a lot of companies that are on the cutting edge of AI, but are also tackling some of the hardest problems in AI. So I wanted to pick his brain about some key AI trends. So the first thing is about data. Okay, so we hear about that people are running out of data. The teams training these foundation models are running about data, but then also that the data tools themselves are lacking because everyone is focused on training and not enough on the data tools. So give us, Robert, kind of your high level view of the state of affairs as far as data in AI.
Yeah, well, the importance of data in AI is something that, of course, many people have identified and have known for a while. But this is actually a really big paradigm shift in how the field of machine learning has been thinking about AI. And if you go back a decade to the ImageNet benchmark, ImageNet is one of the famous computer vision benchmarks where you have tons of images and you try to build models that can classify the images into different categories like cars, cats, dogs, trees, and so on. And a huge amount, if you think about the progress that this benchmark drove in AI, this benchmark really drove progress in computer vision and all of AI for a long period of time. And all of the innovation in this benchmark was really around building better model architectures, trying to innovate on the optimization algorithms to take your ImageNet data set, train a model, and ultimately do better on object recognition. But the interesting thing was that in this benchmark, the data set was considered static. Right? You take your ImageNet data set, you split it into your train and test data, then you train your model, and all the innovation is on the model architecture. Now, we are in a different paradigm where the model architecture is not completely static. There's still innovation there, but it's more transformers are very common. There are a few standard model architectures at this point. The optimization algorithm is much more static. Like we are all using variations of stochastic gradient descent. And where all of the innovation is happening is on the data side. It's like acquiring different sources of data, evaluating which sources of data make sense to train the model on, curating the data, generating synthetic data, like extracting, filtering out low quality data. So I actually think that, especially given how we know how important the quality of the training data is to impact the quality of the resulting model. And the way people are thinking about curating training data and acquiring training data has really shifted over the years. So if back to ImageNet, the kind of data preparation or processing that people did was very limited. You might crop the images, you might scale the images to try to generate, to augment your data set. Now you're using AI to really process and curate the data. That's the big shift. So for example, imagine you're working with a bunch of video data, right? You want to filter out low quality data. How do you do that? That's an AI task, right? To determine you're working with an autonomous vehicle company, right? You have self-driving cars. They have hundreds, millions of miles of driving, tons of video footage, and you're trying to find the most interesting data to train on. A lot of the data might just be driving down an empty road for a long stretch of time, nothing interesting happening. Some of the data is a pedestrian doing some crazy thing. something you've never seen before. That is, not all data is created equal, right? Some data is far more informative or valuable than others. And so a lot of the process is taking all of your data and extracting the most informative, most interesting, highest quality data to train on. And that is very much an AI task. There's a lot here.
And Robert, for the most part, a lot of the tools, at least in the resurgence of data engineering tools 5 years ago, which was centered around pipelines and orchestration tools for structured data, mainly aimed at warehouses and lakehouses, right?
Yeah.
So now we have unstructured data, but increasingly, as you point out, multimodal data.
Yes.
So what's the challenge as far as the tooling around working with that same data and trying to do the same sorts of data processing and data prep that people are accustomed to?
Lots of companies have lots of data, right? And they've acquired all of this data and they're storing all of this data because they believe they can get insights out of the data, right? They want to get value out of it. They want to make decisions. And the way they get value out of the data today is by running SQL queries. They'll run SQL queries, they'll run some simple analytics to learn about their data and to explore it.
For structured data.
For structured data, right? And not because they don't have unstructured data, but because you can't really touch that with your SQL queries. Your SQL queries are not going to operate on PDFs or on videos or images or arbitrary text documents. But the reality is that what you can do with SQL queries is quite limited. Right? The amount of insight you can get. If I compare, imagine I'm a company and I'm trying to get insight about my sales pipeline. Right? The kind of SQL queries that are easy to run are things like asking about which companies have been in certain stages of the pipeline for what certain durations, things, pre-built fields and categories that I've already thought about. But all of the insight is in the notes that the sales representatives are taking, in the videos of the recorded meeting calls, all of these kinds of things. And you're not getting any value out of that today. So I think the way that people will get insights out of data in the future is with AI. Right? They'll have AI read the data, reason about it, and draw conclusions. And that is a very different paradigm. So I imagine data processing shifting from really being a SQL-centric workload to an AI-centric workload. And if it's an AI-centric workload, it's going to be a GPU-centric workload, or perhaps mixed CPU and GPU workload. And the tooling around workloads that are very GPU and AI intensive and very data intensive is practically non-existent, right? This is or it's very immature, this tooling for multimodal data processing. So that's a challenge.
Yeah, because in a future pipeline, you can imagine. I'll throw out a few examples here, right? So I have a piece of text, and then I remove personally identifying information. Then I correct grammatical errors or translate foreign terms, and then I embed, right? So there's like this complicated pipeline that is not really going to be addressed by kind of the data engineering tools from the structured world, right?
Yes, you're going to have AI to do that task that you just described.
Yeah, and then secondly, as you point out, in certain parts of the pipeline, maybe you can use CPU instead of GPU, right? So to say that, okay, we're now in the AI world, it's unstructured, I'm only going to use GPUs for data processing, I don't think that's going to be economically feasible. Right?
No, I don't think that's feasible. Data processing is not just running inference with an LLM or with some model, right? There's lots of other regular processing. If you have video data, you might want to decompress the video, right? You might want to re-encode the video in other formats that are better for downstream consumption, right? You might want to find scene changes between different clips in the movie or the scene. You may want to do transcription, right? You may want to run a vision language model to generate text descriptions. You probably want to run a lot of classifiers to to annotate the video and extract structured information, right? There's some stages will be GPU bound, some will be memory bound because videos are massive, right? Some will be CPU bound. And you're going to want to move toward an architecture where you can disaggregate these different resources, where if GPUs are the bottleneck for a certain stage of processing, you can scale those up. If CPUs are bottleneck for a certain stage of processing, you can scale those up. And of course, you want to be able to stream all of these stages of processing together so that you can keep your GPUs busy while the whole time, right? You don't want to just do one stage of processing, wait for that to finish, then do the next, and so on. And all of these things are areas where the tooling has a long way to go.
And most likely in the types of data that you're describing, which, you can think about a billion images or a few hundred hours of video. I mean, it's almost assumed that you will have to go distributed and scale out, right?
Yes, there is no choice but to really scale the computation. The data is not going to fit on a single machine. You're not going to be able to process it in any reasonable amount of time.
And so everything you've discussed so far around this data challenges around multimodal data, is this a real problem today, or is this or are you forecasting in the future?
So this is something people are running into today, and a lot of, by the way, in the past we were really mostly getting value out of structured data because we had the tools to process structured data and query structured data. We weren't really thinking about what we could do with unstructured data, with other types of multimodal data, and if videos. I keep mentioning video as an example because it's a type of data where there's so much value in it, and yet we are not even scratching the surface of what we could be doing with video data. And as a result, when previously you're in this regime where you can't get much value out of video data or images or other types of data, and so people weren't collecting it as much, right? Because there's less incentive to collect it. Now that generative AI is really unlocking the ability to get value out of all these different types of data, we're going to collect a lot more data, right? Because we're getting more value out of it. And when you talk about the companies we see that we talk to, many of them are looking around at the scaling laws, seeing that, wow, if I train a bigger model with more compute and more data, I can get better results. That's almost a formula for just getting better results, right? There's subtlety to it, but it kind of gives you a roadmap. And so all of these companies we're talking to are saying, hey, we need to enable training on 100x more data, right? Because that's the path to getting better results. And of course, the challenge there is that you didn't build your internal systems to handle 100x more scale, right? You don't build that far in advance. So now to really enable to build the next model and get the next, ship the next AI feature, all of these ML platforms, ML infrastructure is really on the critical path for building and shipping that model, right? And of course, it'll be on the critical path for the next model after that because you need even more data. And so we're finding a lot of responsibility and stress on these ML infrastructure teams who are now, on the critical path for delivering these kinds of results.
So actually, as I was asking you that previous question, I started remembering it at the last Ray Summit in September in San Francisco. There were two talks that caught my attention that I sat in on both of these talks. One was from ByteDance, where they were processing petabyte scale data, which was mainly audio and video pipelines. And then the other one was from Pinterest, and I think that was for
model training
for their really large scale recommender system. So again, they had to do kind of this dance between CPUs and GPUs. But I guess my question is, both companies I just named are super tech forward companies, right? So digital first companies. So do you imagine what you're describing is something that regular enterprises will also have to grapple with, maybe not today, but soon?
I mean, there are always companies that are early adopters, right? And I would say when it comes to AI, a lot of the market is still very early, right? A lot of companies are very much in the exploratory phase of figuring out how to use AI in their business, right? Should they build a chatbot? Do they build internal co-pilots, how do they really incorporate AI in a native way into their products? So that is true. Now, companies like ByteDance and Pinterest are very much at the cutting edge at the frontier of running AI in production. They've been doing this for a long time. And of course, if anyone knows how to work with multimodal data, it's going to be these companies because of just the nature of their products. Now, that said, every company or nearly every company has a lot of data, has its own data, has data about its specific business and the way its customers use its product that they can use to improve their their platform. So this is something that we see every company is going to want to get insights out of data. Right? Every company is going to want to use data to make decisions, and the value is there, the potential is there. The challenge is just the tooling and the infrastructure to really make that possible.
Actually, there's another interesting angle around data and scale, which ties into this new world of really large scale AI models, which is experiments and experimentation, right? So take, for example, you're building an application, an agent, or retrieval augmented generation. The reality is you're probably going to have to play around with different knobs and run experiments. And some of those experiments may start early in the pipeline, like how do I chunk and embed and pre-process my data, right? So sure, you can probably use the default settings, but you're likely going to be leaving a lot of insights on the table. So all these data tools that Robert is describing, I think it seems to play into, if you want to do AI well, you have to be able to run experiments, and data processing and preparation is part of experimentation.
Absolutely. The customization is not just at the level of the model, of fine-tuning the model or the prompt, right? Those are important things that require customization or require experimentation. But there's so many decisions to make at every stage of the pipeline, exactly like you said, from what data to collect, to how to segment or chunk the data, to how to embed it, to what embedding functions to use, how to do retrieval, what to stick into the context if it's a RAG application, right? How to rank the context, the stuff that goes into the context, what model to use, how to fine tune the model, what data to use to fine tune it, whether you're fact checking or the outputs of the model. There's so many decisions to make. And in order to really iterate quickly, you need to be in a position where you can try out different choices and evaluate how well they work, right? And that means, we often recommend that companies overinvest in evals early on, do all the steps by hand, like evaluate not just the end-to-end thing, but individual stages of the pipeline. And because that's ultimately very important for moving quickly as you develop.
And if you don't have the right foundation, computational foundation, these experiments will actually be impossible to pull off, right?
That's right. And I think the need for scale changes depending on where you are in the AI maturity life cycle. You can prototype and experiment at a very small scale using APIs, using a small amount of data, and really iterate on just the nature of the product you're building. Does the product make sense? Does it have product market fit? But once you validate the thing you're trying to build, you're trying to get to production, the considerations tend to change, right? People start to care about cost, about scale, about reliability, about upgrading the model, all of these types of things. And so we see a very different set of challenge at the production phase versus the ideation phase.
So what's your sense of what's the next data type to get popular? So in other words, now obviously unstructured text, super popular, and we're all talking about multimodal, but in order for it to be multimodal, there's got to be another modality. So what's your sense of the next shoe to drop?
Well, images are going to be, image data is starting to be, and I think will be ubiquitous. I think it's for all of the common AI use cases, think about, or many of the common LLM use cases like chatbots, customer support, copilots. A copilot will benefit from seeing a screenshot of what you have on your screen, right? Think about like the computer use type model. A customer support representative will benefit from being able to see an image of a damaged product or a video of a damaged product. So I do think text, images, video, audio are the big ones. And there are a lot of things that you can lump into here. I think people will do a lot with PDFs, right? Just a lot of data like that, but that will be converted to text under the hood and images under the hood. I think the one that will be the most challenging, which we are furthest away from really capitalizing on, is video. Video is everywhere. Video is kind of a very powerful modality in that it combines, images, video, audio. There can be text in the videos as well. And it just is there's so much information there, and it is a massive, in terms of the size of the data, it's just absolutely enormous. So it both poses a very hard infrastructure challenge, but I think it's also a format that people very naturally interact with. And so once I think we have the tooling to really take advantage of video data, it'll be indispensable.
Yeah, and there's some. I think there's also some kind of modeling challenges involved, and people are working on it, which is around video understanding in the true sense. Because right now, video understanding is really, here's a video, produce a transcript. I'll try to understand the video that way. But the reality, as Robert points out, there's so much information in a video, from gestures, from slides in the video, or whatever, right? So that are not being mined properly. Now, Robert, you also have been working with a company that does the reverse, which is to generate video, right?
Yes.
So can you give our audience an overview of what's the state of the art there, and when will we start prompting our way into the next Academy Award-winning movie?
That's a great question. So one of the companies we work with is Runway. They have some of the leading video generation models out there. If you've played with Gen 3 Alpha or any of these,
which, by the way, let me just tell our audience, they are also behind what's now becoming famous, the AI Film Festival.
Yes.
Yeah.
Yes. And their models are incredible. I think if you think about the overall stage of video generation, and it's a rich ecosystem, there's a lot of promising startups in this space. The model quality is still the most important thing that they need to improve, right? If you think about what is the gap, we're at a stage where the videos that we generate are awesome, but they're still difficult to control, right? It's still difficult to go from a clear idea you have in your head to really materializing that in the video.
And how long are the videos that you've seen that have caught your attention?
Well, I think a lot of these companies generate 5 or 10 seconds at a time, maybe more. Of course, you can continue the generation. You can stitch together a number of segments and generate like longer sequences. So there's a lot you can do there. I don't know how far away the Academy Award winning film is, but I do think these tools are going to dramatically will be widely used in various parts of the video creation process very soon.
So one of the phrases you dropped in the conversation earlier was scaling loss.
Mm-hmm.
So we're speaking this week when there's a bunch of headlines about companies, not saying that the scaling loss are over, but scaling loss have slowed down until maybe there's some new model breakthrough, in which case they assume that they will pick up again. But so can you give our audience an update on what's happening in the scaling loss?
Well, first of all, this concept of scaling laws is really one of the major breakthroughs in AI over the past decade. If you go back a decade or more, it wasn't obvious to people at least not to everybody, that scaling was the path to really improving AI capabilities, right? A lot of people were looking more at the algorithmic level. How do we come up with more clever algorithms and strategies versus taking simple techniques and just scaling them? And of course, deep learning falls into this sweet spot of benefiting from increased scale and being able to leverage that. So this is a huge breakthrough, the idea that putting more compute and more data and bigger models into the mix can lead to better results. Now, this is powered by ideas, right? I think there are many different techniques and strategies that are needed to make this work well. And when any given idea or model architecture or perhaps strategy like generating synthetic data or strategy like inference time, how you do inference time compute, may have a finite window of scaling, right? So you take some technique, you push it as far as it goes, that gets you another order of magnitude or 2 orders of magnitude or more. But any given technique has its
Diminishing returns.
Diminishing returns, right? And of course, the continued progress and continued improvement come from new ideas and new strategies. I've heard people say that we're running out of data, right? Well, we can generate data, right? Of course, we have to have good ideas. We have to figure out how to do it, but that's very much doable, right?
Or these companies may have to license data that's behind a firewall, right? So
for sure, licensing data and taking existing data and really improving it. Exactly like you said, there are mistakes in the data out there. There's incorrect data, identifying that, correcting it. There's a lot of room to improve the quality of the data with the existing data that we have. Just determining, separating high quality from low quality data. On the reasoning front, I think there's a lot more mileage to get there by figuring out the right techniques to train these models to enable them to really leverage inference time compute to reason well. So I think AI capabilities are going to continue to grow dramatically. And to make that happen, we're going to have to continue to come up with good ideas.
So as I mentioned, just to close, right? So as I mentioned, you have a unique perch in that Ray is actually the foundation for many of the AI platforms that these leading edge companies are using, including the companies building some of the foundation models we've come to love and use. So can you share some of the things you're hearing? So what should we expect in 2025?
Yeah.
Better reasoning, multi-agent architecture. So what are you excited about?
Well, all of those things you mentioned, I think reasoning capabilities will be far better. I think just specifically one benchmark of reasoning is math. And I think there's a huge amount of interest in and promise in building models that are really good at doing math. Multi-modality, like you've mentioned, will be ubiquitous. Like this is something that's today most of us are using text-based models, right? Text input, text output. But multimodal models, at least text and image, is going to be ubiquitous. I think you covered a lot of ground with the data side of things. People are going to be using AI across the board to get insights out of data, out of types of data that they didn't have a way to use before, that was just sitting there, right? And companies are going to find they have a lot of internal data, documents, design documents, recorded Zoom calls that they weren't doing anything with before, that they assumed had no value, that actually have huge amounts of value. And that's just internal stuff. I think the amount of energy and money that people spend on curating data, on data processing and data preparation is going to explode, far more than actually the amount of, there will be a lot of training, but it's going to explode far more than the amount of money and energy people are spending on training. There's a lot to look forward to.
And actually, uh, just to wrap things up, so data also includes data for post training,
Yes.
which post training can include fine tuning, distillation, quantization, reinforcement learning
Yes.
with human feedback. But some people assume that, okay, so if I'm doing post training, which is fine tuning, I don't need that much data. Well, actually, it depends on how much fine tuning you want to do, how extensive the fine tuning you want to do. So maybe there's still an advantage, Robert, to even in post training to have the sorts of data tools you described, right?
Absolutely. I think there's people do continued training for a reason, which sort of blurs the line between pre-training and fine-tuning, because there's a benefit to doing it. If you really want to get more knowledge and uh, intelligence into the model weights, you're going to benefit from having more high quality data to do that. So I agree there.
Yeah, and for most companies, actually, their platform should really be optimized for post training because very few companies will actually train models from scratch. Correct?
A very few companies will do the pre-train the very largest models. I think many companies will train lots of smaller models, and lots of companies will do post-training, like you said. I think a lot of the quality or what we really like about a lot of the foundation models that we use can be attributed to the post-training stage, which, like you said, is quite complex, and there's growing complexity around post-training.
So a year from now, exactly 12 months from now, the foundation models will be much better, I hope. What do you think?
I believe so.
Okay.
I
And with
hope
that,
so.
thank you, Robert.
Thank you so much.